Bismillahirrahmanirrahim. Today we'll learn about chapter 4, and this chapter 4 is just a revision because of I have teach you already chapter 4, and chapter 4 is on the property function of random variable. You can refer to page 60 of my book, and for this property function of random variable, we have two cases. One is on the discrete random variable, and the other one is the continuous random variable. Now, the main point here is if we look at the theorem of random variable here. So the theorem say that for this random variable, so I take a case of discrete, even though we have learned already. So I take a case of discrete random variable. So the theorem say that for function of x, fx must be greater than 0, where x is element of a real number, and then the summation of fx for all x is equal to 1, and then the property of x element of a equal to summation of x element of a fx. And this is the theorem of property function of random variable. This is a case of discrete random variable. So actually we have learned already these discrete random variables. So I do not want to repeat again for the case of discrete random variable. I want to go to the continuous random variable. So for the continuous random variable, so we go to continuous random variable. We apply the same case. Continuous random variable, and the theorem is the same as the discrete. So for the continuous random variable, we have two parts here. The first one, fx must be greater than 0 for x element of real number, and then instead of summation is for discrete, we use the integration. We use the integration. The integration here is from negative infinity to infinity, fx dx equal to 1. Okay, this is the and then we have C here, the property of for x in between a and b, range of a and b, you can integrate from a to b fx dx. And this thing you can refer to my book at the page of 78. Okay. So these are continuous random variable. Now, for the discrete variable, we have learned already. So even for the continuous variable, we have learned that. Then I will just give you some revision on the continuous variable. This is still on chapter 4. Okay? Now we take one example. Example 4.11. Example 4.11 on the same book. So example 4.11 say that if we had a function fx equal to, so we have 1 over 3, so x in between 4 and 7, then 0 elsewhere. So let's say I want to find I want to prove that the function here, we want to prove that the definition here, we have A, B, and C. We want to prove this thing. So the first one, want to prove that fx is greater than 0. So by looking at this function, we can say that fx is equal to 1 over 3, which is greater than 0. Okay, this we prove A. And B, we can prove B. So if you integrate this limit between 4 and 7, if I integrate the limit between 4 and 7, I integrate between 4 and 7, 1 over 3 dx, this one will be equal to 1. So if you integrate here, now if I integrate here, we have 1 over 3x. So substitute for x is equal to 4 and 7. So if you substitute here, you will get 7 over 3 minus by 4 over 3. This will equal to 3 over 3 or equal to 1. So we have proved two things here. So let's say I want to find this. We prove B. So let's say I want to find what is the probability of x in between let's say 5 and 6, for example. So 5 and 6. So the probability of x in between 5 and 6 is equal to integration of 5 to 6. So 1 over 3 dx. So I will get, so if you integrate here, you get 1 over 3x. So substitute for x equal to 5 and 6. This will give me the answer of 6 over 3 minus by 5 over 3, which is equal to 1 over 3. This is the final answer for this part. Okay? Now, the other part is example 4.12. Example 4.12. So, look at example 4.2. Example 4.12, the same book here. I want to find k value. Let's say my function here is fx, given that fx is equal to kx 0 here. So x in between 2 to 5, 0 elsewhere. I want to find a k value here. I want to find k. So to find k, you can use the definition. The definition is that integration of from negative infinity to infinity, fx dx must equal to 1. Okay? Fx dx must equal to 1. So for this part, our lower limit here, this is referred to lower limit, lower limit, and this part is referred to the upper limit. Now, if I substitute here, so my lower limit here is 2, and the upper limit is 5, and the property function there is kx dx. This must equal to 1. So from here you can get the value of k here. So if you integrate here, we'll have kx raised to over 2 And to substitute for 2 and 5, this must equal to 1. So if I substitute the value of 2 and 5 here, I get 25k over 2 minus by 4k over 2 equal to 1. So which will give me the answer of 21k over 2 is equal to 1, which is k is equal to 2 over 21. This is how we solve the problem here. Okay, k is 2 over 21.